Hello, everybody. Hi. Yes. I suppose we'll get started. My name is Erik Swan. I work at Nike right now, but I'm supposed to say I'm not representing Nike, nor do I want to. I'm a software engineer. I mostly work on the front end, which I'll get into. So we're talking about a client-side application written with React, Redux, Webpack. The title of the talk is about the JavaScript toolchain, which I will be covering as well. First of all, for me, it would be great to get an idea of where everybody is sort of tech-wise, just so I can help gauge what I say. So who here is familiar with the command line? Okay, cool, good number. Who here has worked on an application of any kind, front or back end? Okay, excellent, wonderful. Perfect. So the idea with this talk was you often encounter explanations of technique in isolation, and I found it's really hard to get an idea of how these pieces fit into a bigger system. And seeing a fully fledged example, all the pieces connected, fully integrated, I think is extremely informative. So what I've done is I've made a React boilerplate application that has all the pieces you'd find in any sort of modern. I'm giving you all a link to that repository that you can then use and pick it apart and do whatever you like. And I think it'd be, just as an example, it could be very instructive. You can run with it, use it to make $1 million, whatever, I don't care, it's yours. So I'll be giving that link to you at the end. And so the idea of this talk is to just kind of walk you through it. And so, that said, it's kind of complicated. So I'll have to touch very lightly on some things, and I'm more into detail on things I think will be the highest value for right now. So first of all, what's the client-side application, right? Well, it's a fundamental relationship pattern between machines. It's a relationship pattern. It's an abstract idea, right? So a client can be anything. It can be your computer. When you go on a website, you send out a request. Things happen. Don't worry about it. It gets kind of complicated. But just assume it gets to where it's supposed to go, and it'll be some servers or something, maybe in a bunker in Nevada or wherever. It's going to do its thing, then send you a response, send you the data that you requested. But a client can also be your phone. You go on Facebook, it'll send a request to servers. It could be a doorbell. It could be a refrigerator, looking for the weather or something. It could be a client. It could even be a machine that's typically a server. It can actually act as a client. What I'm trying to make here is that a client is a role that a machine plays. It's not something intrinsic. Machines can be designed to serve a role, but their abstract idea about relationships between machines of a client and a server that I think is useful to understand. So I'm sort of belaboring the point. But a server can also be a laptop. I can host a server here. You can all connect to it. Or it could be some guy who knows where you're connecting. And this is when I found this is where I discovered that if you want to see people in balaclavas on computers, there's no lack of imagery on the internet. So, okay, well, we know what a client-side application is, vaguely. So why is something like React useful? I think this is an important question to ask, and if we can't answer it, we have a problem, right? Why not just use HTML and jQuery? Some people think they've rolled their own for 10 years, and they don't need a framework. It's too much complexity. And that's a valid point. So why not? Well, maybe you should, actually. Maybe you should just write HTML. If your use case is simple, if your website is simply informational, if it's a brochure website, which is something you'll encounter a lot, some company wants to put out an about me, who we are, contact us, whatever. It's a static site. Why complicate things? And so there's a number of sort of gained favor in recent years called Static Site Go. This is one I've used. And then Gatsby here is actually React making static sites, which becomes a sort of circular. It's weird. But if you have more complex use case, is that we encountered the same problems many times and saw ourselves asking the same questions And so we said, can we solve these things ahead of time? Give us a head. And that's really what these are. It's just answering a lot of questions ahead of time. You get to leverage the work of very smart people. And a lot of, which is fantastic. Why not leverage that if you can? So you have Vue here. These are the big three sort of front-end frameworks right now. You have, which is maintained and developed by a vibrant open source community. You have React, maintained and developed by Facebook, and Angular, developed by Google. They've got a lot of money and people working on this stuff. It can help out a lot. So, sure, that's about the only thing worth talking about here. So, okay, 8 parts. I know this is a lot. We only have so much time. I should say as well, if you want to interrupt me at any time for questions, please feel free. So the 8 parts. And I put this slide up because you'll see here these sort of annotations of the technology used for each part of this application. And I think the reason I put this up here, React is only one part of this application. The rest of it is actually completely different technologies handling the rest. React is one part of an application. It's mainly the view. When we're talking about the view, in the context of this, we're talking about components. It's the way that React thinks of the view. But for everything else, styles, I'm using Sass. For state, we have Redux. Some other things, route server, etc. The point is that React is one piece of a greater whole. But also considering this is a lot to cover, that I will be very hand-wavy at the end. We're going to focus on the first 4. I think that'll be the bang for your buck here. So first of all, so again, the idea of the talk, I'll be giving you all React boilerplate. I want to walk through actually getting it up and running together. The first thing that you would do after I give you the link is to basically, you copy the repository, you fork it to your own GitHub profile. If you don't yet have a profile, you have to make one. It's no big deal. You'll probably do it at some point or another if you don't have one. Once you have a repository on your account, I've listed out 5 commands here. I'm not going to go into detail what these are. But in general, what this is doing, you're downloading the repository, you're installing your dependencies, and you're just running the application. That's all this is really doing. Let's do it together. So here I have this React boilerplate application. And I'd like to download it to my machine. So there's, well, actually, the detail I wanted to. All right, we're going to clone the repository. It's going to download a bunch of things. Hey, sorry about that. We're going to go into our application. And install our dependencies.
Do you work in Django also?
I have done Django, yes. Python's probably the other thing that I do.
Okay.
Yeah. So let's take a minute. If you don't know what dependencies are, it's essentially just a list of other this application relies on. It doesn't make sense to bundle them all together because that's redundant. You're copying code everywhere. Instead, it's discrete points and locations. And that just adds another step that when we download our application, we need to also download our dependencies. This step, I am creating an environment file. I'm not really going to talk about that. Don't worry about it too much. And here we are. We're going to run. We're going to build the files, run a server with Webpack. Then in our local host support 9080. Here we are. Fantastic. So the reason I did this is I just wanted you all to see the flow as if you were a developer working on an application. If you don't know all the specific details, it's okay. I've written all this down, and hopefully you can, there's enough information I've written down to explain. So, and I've done some sort of, added a bit of flow to sort of fill out the components, give you something to look at. You can pick this apart and see how I'm changing the screens like this. I have a fun little SD animation here with the drawing of the X. You can pick that apart and see how I do that. So, we're up and running. Fantastic. All right, the toolchain. Okay. Part of what I just did was invoking that toolchain. So before I talk about the toolchain, there's some fundamental problems with JavaScript that I want to talk about. It'll take JavaScript that's written in newer specs with experimental features, and it will transpile it, aka compiling. It will compile fancy JavaScript to plain old browser-compatible vanilla JavaScript that works in any way. So now we get the best of both worlds, right? The ability to write in any sort of features we like. We can even opt in and out of any features we want at any time. It's fantastic. But then we also get browser-compliant JavaScript without having to worry about it. That's the point of Babel. And Babel's the one doing the transformation. Okay. Okay, so what about Webpack? All right, Webpack actually started. Its primary purpose is a lot smaller than what it's been made to do today. All Webpack, its primary purpose, the reason people made it, so that it could be a module bundler. If you're not familiar with what a module is, it's basically, you could say it's another piece of code in a different file. What Webpack does, it looks at your JavaScript. Anytime it sees you trying to import code file, it goes to that file, makes that code available. That's all its primary purpose was, right? In addition to that, we take Babel, we put it in a Webpack, so when Webpack crawls our JavaScript files looking for importing code, at the same time, Babel will then also transpile it into that vanilla JavaScript. Okay, so we have two things going on here. So Babel is a Webpack. Okay, so now we have one tool, but we have other kinds of assets. We've got CSS files, we've got JPEGs, ML files. We don't really want more than one tool to manage all that stuff. It's already complicated enough. So Webpack has become the de facto front-end asset builder for everything. People write plugins to Sass in the CSS. At the same time, it's transforming your JavaScript code. It will also do things like compress your images, do anything you like, really. Add a plugin, put it into Webpack, and if it encounters that file, it will use the plugin that you have indicated to transform it and output it with the rest of your assets. So that's Webpack. Okay. I also want to that Webpack's not the only game in town. There's alternatives for pretty much anything, and I want to point that out, not to get sort of married to any piece of tech in particular, React included, not to get married to it. You know, it's not as in engineering. Sometimes to be a hammer and think everything looks like a nail, right? So we're thinking about use cases here. We're also thinking about different types of tech that may fit our use cases better. So I've indicated here there's a rollup. I haven't used it, but it's out there. It's supposed to be a lot easier to set up than Webpack, is the idea. No config necessary, which can actually be very helpful because Webpack has very complicated config options. And then Parcel is another alternative for this module bundler. All right. So let's talk about React. Let's talk about the React component, which is really the fundamental piece of React. I'm not going to get into everything, but I think I want to hit the main points here. So what's one cool thing that React does that makes it desirable? Well, it does this thing Well, let me first establish the problem on a web page. Removing or adding elements, what we say modifying the DOM, document object model, is a really expensive operation. JavaScript execution. JavaScript is much cheaper to do. So one thing React does is it tracks the entire HTML tree, all your elements, all the attributes, everything. Inside JavaScript, it mirrors what's happening in the browser. When changes happen, especially changes in state that cause things to move around or just change, behind the scenes, JavaScript makes all the changes to the DOM. Once it's done, once all of the updates or everything is done, it sort of commits those changes to the DOM. The idea being that using the cheaper JavaScript execution, we can eliminate steps in changing the DOM, making it more performant. That's the idea. If you can imagine, there are some operations that may switch to elements, and then an operation immediately after switches them back. If it happens just in JavaScript, no changes to the DOM occur, we have no performance issues. That's kind of the idea. It works pretty well, but it's important to know this concept because it's very relevant to a lot of the other things React makes you do. Also, like real HTML, it has a parent. So component itself, I would split into three pieces. Or I guess I would point out three pieces of information that are relevant to this component functions. We have props, which is just information passed into the component, or properties. Props just short for properties. Components will receive this information from their parent component or elsewhere. But most of the time, a prop is passed from a parent into a child component. Within a component, it also tracks its state. Where state is different than props is that state is generally not received. Say a user's clicked a button and changed its screen. You can react to that change in state using this feature of components. We also have JSX, which is just HTML and JavaScript. And it was really great because now we don't have to touch HTML files at all, really. It does some other things behind the scenes, which are nice. But that's all JSX is. There's an event with this component mounted. The change in state will then trigger an event that says, we updated. The lifecycle mostly refers to the let me actually show you. Updating. There's a number of things it does behind the scenes as it updates, but it exposes some events, some hooks that you can get into as it goes through its sort of render thing pretty much constantly. And that's what the lifecycle means. It is mostly that render looping in response to changes in the application. So there's a couple lifecycle methods that I've written out. Component will mount before your component mounts to the page. I actually think this is deprecated. It changes. And this is not exhaustive. Component will and component will be leaving. Component did update. Just had a state change or something that initiated it. And then we can do something after that. We can even look at the props before and after and decide, well, is this where I should do more things? Last thing I'll mention, just a small bit, events. React wraps events with its own thing. React likes to just wrap everything with its own thing. It requires a slight change in the way you do things at times. That's the way it is. But that's sort of a basic understanding of a component. So I'll also be making these slides. Obviously, trying to make some. I'll make this available. Maybe I'll put it on a repository or something. Yes.
So among your coworkers or in your own experience at the component level, have you strong opinions about Vue versus Angular 2 versus React? Not just in terms of doing the same thing in different ways, but some reason why clearly React would be the way.
When you're making a website, you're working on an application, you have a palette, right? It's a set of colors. It's usually a brand thing. Have brand color 1, brand color 2, and not have to paste hex code everywhere or something. Mixins are basically functions, so we have something introduced to CSS, which it does not have usually. And the mixins are fantastic. You can do all kinds of great stuff to automate, make your styles more modular. And you have all these other sorts of things that, loops, flow control, and such. Lists, different data types that you can play with. It sort of becomes a pseudo-programming language itself. So, and that can enable you to do some good stuff that you couldn't do otherwise. So I've mentioned here, it may be a bit premature, but there is sort of a split in the CSS community right now. Big debate raging about the old style, you can say plain CSS, or these preprocessors. This is the new style, which is CSS and JavaScript. When it first came out, it was super controversial. People had this knee-jerk reaction of thing we were trying to avoid over the past 15 years or wherever. You can't talk to JavaScript really, so you kind of have to duplicate things. CSS. You can write plain CSS and Sass and be just fine. You won't be using any features you could be, which it's a bit harder. It's a different syntax with Glamour. The way that you put it in components is a bit weird. So in this Glamour React thing, I felt it was, especially if it was just too much. I felt Sass was a better solution. And I personally also really don't like camel case CSS properties. So okay, let's talk about the style architecture of this application. Because it's deceptive. It's not a programming language. Some people might take that to mean that it's easy or simple. It's actually really, and there's a lot to know, a lot of domain knowledge involved with CSS. So let me show you actually how to organize the styles of this application. This is where I go first. We have our fonts, nothing spectacular. We have some animation styles that I've added just to give a bit some modular, some easy animations. And we've got, now I won't list them all, but we've got sort of, so that's one level, there's two levels. The lower level component based style sheets. So for a component like the one that we looked at earlier, it will have its own. Looks like this. And here you can see some of the Sass features in action. You can see there's a variable. Right here is me using a mixin, which again is like a function. So I'm passing arguments. If you've used Python, these are keyword arguments, not positional. Here it's nested. Nesting is not something you can do in CSS. That's, I think, all there really is to point out right now as far as architecture of these styles. I'm not going to get into this, but I will mention being classes is a problem you're going to have to solve. There's many different solutions out there. There's some best practices, many different solutions out there. There's some best practices. I showed you nesting, but really don't nest if you can avoid it. Only use classes, don't use IDs. Don't use tag selectors like H1. Use classes for everything, and you will have a lot fewer problems with specifying things down the line. That's also why you don't want to nest. It's for specificity. You don't know what specificity is, I can't get into it right now, but these are just sort of general things that I've learned over my time. Oh, also, should you use a CS framework like Bootstrap or Foundation? No, I say no. Some people, all they know is Bootstrap. I've run into people who are Bootstrap developers, and I just go, ugh. It's like being a pro in WordPress and not PHP. You know, it's more specific domain knowledge, which is not as translatable. It's vertical, I guess. In any case, Bootstrap was made to solve a problem that is no longer relevant to me. Yeah, it was before Flexbox. This was before Grid. So it gave you the responsive Grid functionality, which was great day. But now we have Flexbox. We have Grid. We don't need it, in my opinion. Okay, context again. Moved away from styles. We're going to talk about state. Oh, state is complicated. You can see React handles state itself on a component level. We actually kind of ignore that a little bit and implement our own tech to manage state. Let me talk about that. Let me talk about why we're using Redux and what Redux is. So Redux provides global state. Components naturally are local state. Track state for themselves. Any children they can pass state to. But if you want to go up, that becomes very difficult. Not only that, but when you're using so much component state, you get these very complicated trees of how state flows through your application, which can be very hard to remember, understand, come back to. So there's a couple of problems with using React. So the solution was, well, okay, what if we just put state in a big object? In the same, and anybody can. That's Redux. State is complicated, Redux is not. Redux is a big object that contains information about the state of your application. That's it. What it allows you to do is create these three things, which I'll talk about, which lets you change that big object. So to look for things, you have a single place to put things, you can organize that object in whatever way you like. Put a lot of data in there. Typically that's what's done. Okay, so we have Redux. That way the smallest button can change state, and a button all the way on the other side of the application can then change it. You don't have to worry about this complicated tree of how state is flowing. It's kind of the idea. There's a bit of pushback on Redux, but for now, it is a useful solution, I think. So we have three parts, and this will get a little abstract. We have the reducer. These names are kind of dumb. We have a reducer. All a reducer does is it's an object, and it puts that object in your state. It sort of determines, it's like, okay, where does this object go? It goes and do the thing, put it in state. That's all it does. It accepts an object, puts it in state. Nothing more complicated than that. You have an action. All right. Actions create that object that tells reducers what to do. That's all actions are. In these files as well, you can see how simple these things really are. Then we have a selector. Selectors take things out of state. That's it. So we got the thing that changes the state, the thing that tells you how to change it, the thing that takes things out of state. So you can see what this might look like. This is a reducer. It's a switch case. That's it, really. It receives its old state. The action, as I mentioned, an object. Thank you. Pick whatever switch case is relevant and return a brand new state object with data from your action. It's really just a switch case. Here's an act actions. Set placeholder data. An action has two. It always has a type. This is what selects the switch case. And it sometimes has a payload. Payload is the information that you will probably be putting into state. But it can also include other things that tell the reducer how to state. It's whatever you want to put in there, really. But I have an example of both. An action can be this simple. Placeholder data. All you do is you feed this action into the reducer, and it already knows what to do. It deletes its data. Selectives. This gets a little weird. This top one is fairly simple. It takes an object and it accesses a property. That's it. It's pretty much as basic as you can get. I'm using some ES6 JavaScript here, plus you can see the question mark, something a bit unusual. You may see that in Angular. But the concept here is that this is just a function that then accesses this property and returns it. That way I don't have to remember how to get there in the state tree. It's written down. Now, okay. This is a more complicated selector, clearly, and I'm tough. It just outputs the saved response. It doesn't do any processing. It's function output. So when you're selecting, or actually in a selector, when you're doing a ton of operations, like if you're doing a filter, mapping over something, you're looping through something, can potentially be a very expensive operation. When it's memoized, the first time you invoke this function, it's expensive. But every time after that, it's nothing. It's cached. So it's just for performance doing. Okay, this is the hand-waving part. Routing. If you don't know what routing is, it's to a website, example.com. It's everything after that slash. Example.com /about/person. Everything after that slash is your route. Just kind of a way to segment your application. Typically, when HTML first, entered the scene, it would correspond directly to HTML files. You would have HTML, that would be example.com. Example.com /about.html would take you to about.html. However, this uses a special router. It doesn't do any of that. It uses a client-side router, which is a little bit special. Instead of actually making a new server request to go to a different page, the application actually doesn't serve you new information. It's the same application. It tricks you. What it does is you route in the browser, it doesn't actually change the page. It's very clever that way. And so you don't have to load, you don't have to download anything, you don't have to load new stuff. It's sort of tricking you to think you're changing, but you're still in the same application. Sorry, that's not the greatest explanation. It's very hand-wavy. Go ahead, pull this apart in the application. You'll see clearly where it says routes. I'm serving